All right, we're coming back with more addition and subtraction of rational expressions. We have two more examples to go through. These were a little bit beefier, so I wanted to take more time and have them individually. So I have x plus 3 over x squared plus x minus 2 plus 2 over x squared minus 1. Now in this example, I'm going to have to factor both denominators. So let's go through with our first denominator, x squared plus x minus 2. So what multiplies to negative 2 and adds to positive 1? A times c adding to b. And those factors are going to be a negative 1 and a positive 2. 2 minus 1 is 1, and 2 times the negative 1. Cool. So those factors are x minus 1 and x plus 2. And what do you notice about the next one? Did you catch it? Do you see? The next expression's denominator is a difference of 2 squares. What is the square root of x squared? It's just x. What's the square root of the 1? It's a 1. Because it's a difference of 2 squares, I need an x plus 1 and an x minus 1. Okay, so everything together in factored form. There we go. X plus 3 over x plus 2x minus 1 plus 2 over x plus 1, x minus 1. All right, look at your denominators. Make sure you have everything represented. In the first one, I need an x plus 2 and an x minus 1. In the second one, I need an x plus 1 and an x minus 1. So both of them have that common term or common factor of x minus 1, but I gotta have the others as well. So our common denominator is 3 factors, x plus 2, x minus 1, and x plus 1, all of them. Okay, what is the first missing from the denominator? It's got the x plus 2, it's got the x minus 1, that's right. It doesn't have the x plus 1, it had the x minus 1. Okay, in our second expression, 2 over x plus 1, x minus 1, that guy is missing the x plus 2 factor, so I need to multiply that in numerator and denominator. So here's everything, there it is, with all those denominators. Okay, alrighty, now you got to clean it all up. In order to do that, we're going to have to multiply x plus 3 and x plus 1 together. Remember, if you guys like the box method for that one, let's do that one off to the side and see what we get. So I have to multiply an x plus 3 and an x plus 1. That'll give me x squared plus 3x plus 1x plus 3, which is an x squared plus 4x plus 3. Okay, and then in the numerator of the other one, we're just distributing a 2. So the 2 multiplied by x plus 2 will give us a 2x plus 4. So here's x squared plus 4x plus 3 plus the 2x plus 4 all over that common denominator. Okay, combine your like terms. So I have a 4x I can add with a 2x, and a 3 I can add with a 4. So I get x squared plus 6x plus 7 all over that common denominator. And I know it looks like we could probably factor that numerator, but we really can't. The factors of 7 adding to 6, let's see, they would be 7 and 1, both positive or negative, and there's no way to make that happen. So you can't reduce that anymore. That is your final answer. Okay, so that one had an extra bit of factoring, really big common denominator. Multiplying stuff back together, combining it, we had a lot with that guy. Okay, let's try the last one. Here we go. X over x squared minus 10x plus 5 minus, be careful with that minus sign, x minus 4 over 2 multiplied by x minus 10. Okay, denominator of the second one's pretty easy. That's just a GCF. 2 multiplied by x minus 5. Okay, got that one. And then the denominator of the first expression, what multiplies to positive 25 and adds to negative 10? That's got to be a negative 5 and a negative 5. Put your little x's over top. So it's x minus 5, x minus 5. Okay. There are both terms in factored form. Okay, let's check our common denominators. Let's look to see. The first one actually has 2 x minus 5s. The second one has a 2 multiplied by the x minus 5. So they have 1 in common already, so I've got to have 1 x minus 5. I also have to have a second x minus 5, and that GCF is the 2. Okay, so as we multiply through, let's look to see what parts need to be multiplied. The first expression does not have the 2 in the denominator, so I need to multiply it in numerator and denominator. Okay. In the next expression, the term that it is missing is the second x minus 5 factor. So I need to multiply that in numerator and denominator. So there's everything rewritten. Okay, before we can subtract, we've got to do 2 multiplied by x. So that's just 2x. Okay, so that numerator for the first one is just 2x. Got that. But we need to get x minus 4 multiplied by x minus 5. Let's tuck that over to the side. Here we go. Multiply through. X minus 4 multiplied by x minus 5 gives me x squared minus 4x minus 5x plus 20. So that's an x squared minus 9x plus 20. Okay, so that's what we should have in our numerator, 2x minus x squared minus 9x plus 20. Okay, but what happens is we are subtracting the entire x squared plus 9x, minus 9x plus 20. So when I distribute that negative, that's why we have in the next set 2x minus x squared plus 9x minus 20. Okay, and we can combine some like terms, the 2x and the 9x, giving us x squared minus negative x squared plus 11x minus 20 all over that common denominator. You could try to factor the numerator. It's not going to work. So there's our final answer. Again, that final answer is negative x squared plus 11x minus 20 all over 2 multiplied by x minus 5 multiplied by x minus 5. Nothing to reduce, we're all done. Thanks for coming back for that second little part. I just want to make sure we had enough time to do those. Hopefully you guys have a good one. Check with us if you need some help.